Hello everyone, welcome to our YouTube channel. We are starting a series on Linux tutorials. We would be covering topics from basics to some advanced features of Linux in the coming days. Today's topic is Introduction to Linux. But before we start, please subscribe to our YouTube channel in case you have not, so that you don't miss the upcoming session. So let's get started with the today's session. So this is what we would be covering today: the history of Linux, flavors of Linux, advantages and disadvantages of Linux, Linux directory structure, what is kernel, and the boot structure. History of Linux. Now the history is pretty interesting. In 1991, Linus Torvalds, a student at the University of Helsinki, Finland, started writing its own code. He thought to have a freely available academic version of Unix, and that is the reason mainly he started to write his own code. Now later, this became the Linux kernel. He wrote this program specially for his own PC as he wanted to use a Unix 386 Intel computer, but he really couldn't afford it. He did it on the Minix using the GNU-C compiler. GNU-C compiler is still the main choice of compiled Linux code, by the way, but the other compilers are also used, like the Intel C compiler. Now, he started this project just for the fun, but ended up with such a large project, which almost, Linux is being used at every corner of the world. Now, about the naming, firstly, he wanted to name it as Frex, but later it became Linux. Now, he published the Linux kernel under his own license and was restricted to use as commercially. Linux uses most of its tools from the GNU software and are under GNU copyright. In 1992, he released the kernel under GNU public license. Flavors of Linux. Now, what are the flavors of Linux? There are actually a lot of flavors available currently in the market. You could download it, you could use it according to your way, you could modify according to your needs. But these are some of the uh, commonly used flavors in Linux around the world. Red Hat, CentOS, Rocky Linux, which is mainly started as a replacement of CentOS, Fedora, Ubuntu, Debian, OpenSUSE, Mandriva, Gentoo, and Kali Linux. Now coming to the advantages of Linux, these are just the few advantages. There are a lot of the advantages, but I thought let's discuss the important ones. Now, first is open source. As it is open source, its source code is easily available. Anyone having programming knowledge can customize the operating system according to his needs the way he wants. One can contribute, modify, distribute, and enhance the code for any purpose as well. Second is security. The Linux security feature is the main reason that is most favorable option for the developers. It is not completely safe, but yeah, I mean at the same time it's less vulnerable than others as well. Each application needs to authorize by the admin user. The virus is not executed until the administrator provides the access password. Linux systems do not require any antivirus program, and that is the main reason that if any organization is thinking from a security point of view, Linux is the most favored operating system. Next is free. Certainly, the biggest advantage of Linux system is that it is free to use. I mean, it's one of the major cost-cutting tool for any organization. So we can easily download it, and there is no need to buy the license for it as well. Next is stability. Linux is more stable than any of the operating systems. Linux Linux does not require reboot to the Linux does not require to reboot the system for any kind of maintenance purpose, be it you're updating packages, applying patch, or any of the thing. It rarely hangs or slow down, and it has big uptimes. Next is performance. Linux system provides high performance over different networks. It is capable of handling a large number of users simultaneously, which is again the next advantage is multitasking. It is a multitasking operating system, meaning it can run multiple tasks simultaneously without affecting the system speed. Now, at the same time, Linux does have some disadvantages as well. Few of them are adaptation. So Linux is a bit technical in nature. Okay, so for people who are less expertise in computers, it can be hard to understand Linux. I have mainly seen the engineers who are kind of habitual to Windows operating system. They kind of face some issues, when adapting to the Linux systems because they are not used to the CLA or the interface uh, Linux provides. Now, most users find it difficult to adapt to Linux due to its terminals used. Uh, so the terminals are mainly the command line interface where you need to enter specific command in order to complete task. Next one is software compatibility. Now, popular applications which are made for Windows or Mac are not available for Linux. So many developers are actually not interested in making software for Linux due to its small market value because it's free, it's GNU. So that is the reason people do not find it monetarily benefiting them. So they don't make it. Now, one of the example is MS Office, iTunes, or Photoshop. Even though there are alternative to these softwares, these cannot match to the original level as well. Next one is gaming. Similar to software, games too doesn't natively support Linux because Linux is not a platform which is widely used for gaming developers, or gaming developers are not much interested in Linux. The next one is hardware compatibility. Almost all hardwares in today's Linux can be connected. I mean, can be used. So earlier, there were we used to find issues with hardware compatibility, like we had to carry specific drivers to install on any of the operating on any of the Linux flavors. But yeah, I mean, there are still few hardwares. Those are like still not compatible with the Linux operating systems. Next one is vulnerable to attacks through buggy packages. I mean, similar in contradictory to what we saw in the advantages, where all the packages were available. Now, if any of those packages are, say, have a security loophole, or anyone could execute a shell script and gain access, that can be very fatal for any organization. So these are some of the disadvantages. Now, Linux directory structure. Now, what is the Linux directory structure? The base of the Linux file system is root. I mean, it starts with root. Root is denoted by slash, and everything it starts with, it's with the root directory. Common top level directories are slash. Slash is again the root directory that forms the base of the file system. Bin Bin contains the executable programs that are part of Linux operating systems. So many Linux commands, which we would be covering in the upcoming sessions, like cat, cp, or any common commands are located in the bin. etc contains most system configuration files and the initialization scripts. Slash home is an home directory, conventional location for the home directories of all the users. Users by default log into this directory. For example, if I create a user, say user 1, the home directory would be slash home slash user 1. TMP is a temporary directory that any user can use as a scratch directory, basically, meaning that the contents of the directory are not considered important and are usually deleted every time whenever the system boots. OPT is an optional or third party software directory where you can install any of the third party package that you downloaded. For example, you downloaded specific utility for yourself, so you can enter it under opt and install it /usr. So user related programs contains the subdirectories for many important programs such as the UI and the online manual as well. /var contains various system files such as logs as well as directories for holding other informations such as files for web servers and FTP servers. Lib, it contains kernel modules and containing library files including the loadable driver modules which are needed to boot the system. Sbin, Sbin are binary executable programs for an administrator. It contains executable files representing commands typically used for system administration tasks. Now, there are certain system admin commands like mount or unmount or halt or shutdown. They all reside in the sbin directory. Now, there are few other directories as well, which are probably not, which you may not encounter in your daily usage, but I mean they do exist. For example, /boot, it contains all the boot related information. /dev, it contains all the devices information. Lost plus found, you would find this in every directory that you create. Then we have /media, mnt. Proc is an important from a system point of view. It is a virtual and pseudo file system to contain info about all the running processes with a specific process ID or PID. So we would again see all the process related information in the upcoming sessions. /run, /srv, and /sys. I mean they are hardly used. I mean you will not require to log into or go to these directories for any of these tasks. So, I mean, this is just for your information. You can check this. Okay, moving to next. What is kernel? Now, kernel is a special piece of code, which is a core component of Linux. It is actually the main component of a Linux and is the core interface between the hardware and software. It basically communicates between the two managing resources as efficiently as possible. The kernel is so named because, like a seed inside a hard shell, it exists within the OS and control all the major functions of the hardware, whether it's phone, laptop, server, or any kind of computer. Now, this is just a graphical representation of how a kernel would interact. For example, you would see process 1, process 2, process 3. So, I mean, you can just replace it with, say, you are running an applications and these are the 3 applications. So the application is not directly contacting the hardware or is not connected to the hardware directly. Kernel is in the middle tier here. Kernel is responsible for getting all the details from the process, say the application, and connecting with the hardware and then responding back. So that's what the kernel would do. Now the kernel has four main jobs: memory management, which keeps a track of how much memory is used to store what and where. Process management, determine which processes can use the centralized processing, when and for how long. Device drivers act as a mediator interpreter between the hardware process, the one we discussed now, and systems call and security, which is like receiving request for service from the processes. So this was very basic information about the Linux kernel here. Next is boot process. Now, what is the boot process? So whenever a laptop, a Linux system starts, it has to go through a certain process. Now, if you have seen it, you would see some commands loading while the Linux is getting started, right? Now, what is the boot process? There are mainly 6 stages in this boot process. Any of the boot, any of these stages encounters any error due to whatever reason, the boot would fail. your Linux system will not boot. Now, the first one, start with the BIOS. Okay, BIOS is basic output system. It executes MBR. BIOS also does some health checks to the system, and the bootloader program searches, loads, and executes, and then we move to the next stage, that is MBR. MBR is the master boot record. It is generally located at the first sector of the bootable disk. Now it is usually Dev HDA or Dev SDA. Master boot record executes the grub, which is the loader. Grub stands for Grand Unified Bootloader, which in turn executes the kernel. Now, if you have multiple kernels installed on your system, grubs give you an option to either select a default one, or you get a choice when you are starting your Linux system to select a specific kernel. Now, the first stage kernel executes as bin init. Now, kernel boot process, basically what happens is the file mounts the root system according to what is specified against the root in the grub.conf file. So we have a specific etc grub.conf file, and kernel runs the program as bin init. Now, since init was the first program to run by kernel Linux, it has been the number one process ID or PID number one. You would see the process command and grep init where you can check the PID. Now, after that, the fifth stage, which is init executes the run level programs. Init examines the etc init files to decide on which run level I want to go. Okay, run level is again like there are 6 run levels in Linux: 0, 1, 2, 3, 4, 5, 6. Now, just for the basic information on this, uh, in majority of the cases, 3 is what the run level is used. 3 is the command line interface. Now init executes that run level program. It identifies, okay, whatever run level I have been set, I need to load all those programs which are set for this particular run level. Now, the sixth and final stage, how would it recognize whether which run levels, which programs to load according to the run level? It would go into this file etc rc.d. rc star is rc run level 1. So if my run level is 3, it would be rc3.d, and under that it will have the links or the programs which the kernel should be loading or starting up. So these are the main 6 level of 6 stages of the boot process that Linux follows when it starts. Okay, that's all we had for today. I hope you had a great learning sessions. Do comment on this video and let us know your feedback. And thank you for watching this video. Bye. Hello friends, welcome to our YouTube channel. In our Linux tutorial series, today we would be talking about the VI editor, also known as the greatest editor on the earth, and learn few basic usage as well. So let's get started. This is what we would be covering today. History of VI editor, what is VI editor, modes, and some basic usage. First of all, the history. From where does this VI comes? So the original code for VI was written by Bill Joy way back in 1976 as the visual mode for a line editor called X that Joy had written with Chuck Haley. Bill Joy's X version of 1.1 was released as part of the first BSD Unix release in March 1978. So it was not until version 2.0 of X released as part of the second BSD in May 1979 that the editor was installed under the name of VI. Okay. Some current implementation of VI can also trace their source code to Billjoy. Others are completely new, largely compatible with the re-implementation. As per the 2009 survey of the Linux Journal, it was found that VI was the most widely used text editor among the respondents, beating GEdit. Now GEdit is also another popular uh, uh, file editor tool, which is kind of the second most widely used editor after VI. So that's the reach of the VI across the world. So what is VI editor? VI editor is basically a tool to create, edit, view files on Linux system, and it's by default available on all Linux distributions. Okay. There are also other usage of the VI editor, as in, if you go in the advanced mode, you could also execute few bash scripting commands while you are in the VI editor. So hopefully we'll cover that in the in our future uh, tutorial series. But yeah, I mean the basic usage is this: create, edit, and view files on the Linux system. Now, uh, diving more into how VI works, what are the modes, and what could where how to use it. Okay, so modes. So it mainly has two main modes. One is the command mode, and the second is the insert mode. Now, when VI starts, is it's basically start in the command mode. You can also call it as a read-only mode. This mode is where VI interprets any characters which you type as command, and thus does not display them on your screen when you're typing. So this mode will also allow you to move through a file and to delete, copy, or paste any piece of text that you want to. To enter into the command mode, uh, we I mean by default it enters into the command mode, but if you are in some other mode, for example the insert mode, so you'll have to just press escape key, which would take you back to the command mode. And in case you are you are already in the command mode, escaping the key would probably give you a beep sound on your computer or flash the whole screen. That's kind of another behavior of VI. Second mode is the insert mode. Now, insert mode enables you to edit the file. Everything that you type in this mode is interpreted as input, and um, it is displayed on the screen, and it's added to the file as well. As mentioned, the VI always starts in the command mode. Okay, so to go into the insert mode, you will have to press the escape key, which will put you back into the command mode again. Moving on to the common usage. Now these are the very basic common usage, and it will take some practice and time for you to master these basic usages. Okay, these are the options that you would need in your day-to-day life. So yeah, I mean it will come with the practice. So I is to go in the insert mode. O is to go in insert mode while putting you on the new line as well. Escape to come out of the insert mode. W is to write the changes we have done to the file. WQ to write the file and quit. WQ exclamation. Now there is another usage of this. So forcefully save and quit. So mainly encountered when you don't have write permissions, or basically it's related to the permissions, whether you're not allowed to write on the file. So sometimes you will also see an error when if you're not allowed to write on that file, you would see an error even after using this command. Colon Q is to quit the file. For example, you are in the command mode and you want to just quit the file, you can do that, okay, with colon Q. Now, if there are any changes made, it will warn you about the changes, and it will not allow you to quit. For example, it will give you some warning at the bottom of your screen. We would be covering all these commands in the practical as well. Colon Q exclamation, so forcefully quit without saving any changes. So if you have done any changes and you realize that you don't want to save this, so you can just use this command. File operations. So these are the basic usage of the file operations, that it's very handy to use it. I mean, I use it almost daily when I'm using VI. YY, it's YY as in you'll have to press YY two times on your keyboard. So to copy the line, DD is to delete or cut the line. P is to paste or uh, copy the line. You copy it through YY or DD, and U is for undo changes. Now let's do some practical. Okay. So for example, if you open any new file, if you open any new file, say new hyphen file which does not exist, so this is what you would see. Now pressing enter, right? Pressing I. So I'm pressing I. It will give you. It will take you into the insert mode. You can see at the bottom of the screen that the mode is insert now. So this is the new file. Now to come out of this insert mode, I'll simply press escape. Okay. You'll see that what I'm typing stuff. Okay. Now by mistake I pressed enter or some key which started which took me into the UI, into the insert mode, and it started typing as well. For example, say I'm typing something, so you would see the error at the bottom of the file, no previous regular expression. It means that it acted as some VI related command, and it was not able to find the input for that command. Okay. So pressing O, pressing O would take me to the new line and also put me into the insert mode. This is new line. Okay. Escape. Again, I am back in uh, my read only mode, which is my command mode. Colon W. It will save the changes that I have written. Okay. Now just notice this. I've just added. I've saved my changes. Now at this point of time, if I just do quit, I'll be able to quit it since I've already written the changes, right? Now, if I open that file again and say write these is 2-3 lines code. Okay. Now I'm not saving anything and I try to say quit. It will give me a warning at the bottom of the screen, right? No write since last change, add exclamation to override. Okay. Now if I don't want to save these changes and say uh, you know just quit this, what I'll do is I'll quit this by adding exclamation mark. Okay. Now if I open that file again, you will see the changes were not saved. Okay. New changes again. Now if I don't want to say I want to write and quit, so either I can use a W Q or WK exclamation mark. Okay. In any case, it would take me out of this file, and it will save the changes. Now, um, uh, this will also quickly cover the file operation. So these are all the basic operations that you would see related to file. For another common one that I encountered is, yeah, another common one. Another common file operations that I use it almost daily is how to copy paste the contents, and how to make my work faster. So maybe we'll use some other files. Oh, by the way, as mentioned in my last video, right? I mean, the command are case sensitive. So small q, or the non-capital Q would work to quit, but not the capital one. So this is what happens. I mean, it will not interpret that capital Q as a command and will give you an error. So we'll have to be very careful when using the commands in the Linux. Okay. So next is the file operations. So we'll, for example, use a long file. Simpler one. Okay. So this is my number files. For example, I just want to copy paste. So I'll do double Y and P. So just copy paste it. Uh, now, if I want to delete it, for example, I want to delete the 16 number line number 16. Okay, so I'll just say delete. Now, if I uh, write and quit, of course it will save the changes, right? So you see, I just opened the file again and pressed P. I mean, to paste the last copied cut or the deleted number, and it gave me an error. And the reason because is, the data it stores is before you quit the file. I mean, it will only store that data, whatever in its memory. Once you quit the file, that data is gone, so you will not be able to use any of that after you reopen that file again. So let me just give you, maybe we could use the long file. So for example, say I would do cut, and I would like to paste it here. Okay, and it would paste it on the next line from where your cursor is. Okay, uh, so, and I want to undo my changes. I'll just simply press U. Okay, so you must have noticed that I am not in insert mode. Okay, I'm in command mode. So whatever input I am giving, it is interpreting as a command to that file, and that's why that command is not getting displayed on the screen. As in, it's not getting typed in the file, and VI is just interpreting that as a command that it wants to execute. Okay. Another quick. So you see, I also made some changes, and I don't want to save it, and it's giving me an error. So I'll just use exclamation. Another important another important file operation related command is, uh, specifying the numbers of lines you want to copy. For example, say I'm at the top of the file and I want to copy 5 lines. So I would say 5 YY. At the bottom, you would see 5 lines young, means 5 lines copied, and I would just say P. So the 5 lines are pasted here. Similar is your with the delete. So if I say 5dd, it will delete 5 lines. So at the bottom it would say 5 fewer lines. Okay. Now if you want to uh, clear the whole file, so the command is d shift g. So no lines in buffer. It would clear all the files. Okay. So I pressed undo and it brought me back all my data. Okay. So these are the common usage of the file operations as well. Okay, so that's all we had for today to cover. Do let us know in the comments your comments about the video and what all topics you would like us to cover in our Linux tutorials as well. Thank you. Bye. Hello everyone. Welcome to our YouTube channel. In our Linux tutorial series, today we would be talking about the user and group management in Linux. So this is what we would be covering today. Users and group in Linux, a difference between a super user and a normal user, how to create, edit, delete users and groups, and understanding etc password, etc group, etc shadow files, and how they relate to users and group, and then we would be covering quick practicals. Okay. So what are user and group in Linux? So any user which needs to be authenticated on a system to be used and provide a specific environment for him to work on. A user is actually an entity that can access the allowed file system and perform various tasks. So not only in Linux, right? The user, even if we log into any system, say for example, we log into a Gmail account. So at the end of the day, it's a user ID that we are logging into. And for example, I log into my Gmail account, so I get an environment. For example, I get to see my users, my inbox, and all the mails which I have got, all the other tabs, all the settings. I can access the drive. A drive is actually the classic example in this sense. For example, if I log into my drive account, so only the files which I have created or have been shared with me and the files which I have access to, I can only access those files. So those are that. So that is like the controlled, allowed file system, and this is my environment where I could perform certain tasks. So that is the user. Group is an efficient way to manage the access requirements of say a set of users, instead of you having to manage the permissions of the users individually. So it's nothing but you can gather the set of users. For example, in an organization, say we have two set of users. One is belonging to the HR section, and the other is to back office section. Now these two groups would have a different access rights. So a new person joins into the HR department. Okay, so the admin would know which group he should be in, so that by default all those HR related access policy is applied to that user, and similarly for the back office group. So that is the users and group in the Linux as well. What is super user and normal users? So you might be hearing about super user in terms of Linux for the first time, maybe. So we have kind of two set of users here: super user and a normal user. A super user has full access to the system and its file system. It can manage and create other super user and normal users. By default, root is the super user on Linux system. So Once you are logged in as a root, you have full control of the system, and you can do whatever you want on the system. That's why in most cases, in larger organizations as well, uh, the servers, for example, the Linux based servers, they are not accessed directly through root. In my experience earlier as a sysadmin, we used to get a normal user account with certain rights to execute certain commands, which maybe it reduces the risk of harming the system intentionally or unintentionally. So that is the policy followed across a lot of organization, and I have seen individuals as well, using a normal account instead of the root account on their own systems. A normal user, he has limited access or maybe no access to its file system. It's all depend to the admin, what kind of access he gives. Maybe he could be restricted to his home directory itself. Permissions are defined by the super user and cannot manage or create other normal users as well. A normal user can become super user through a sudo command. Now there is a utility known as sudo, which allows you to become a super user. It's altogether a different configuration. You have to edit certain configuration files, etc sudoers, to that normal user to be recognized as a sudo user as well. We would probably cover in some uh, other other chapter. Uh, Now, how are the users and groups managed? So these are some of the basic command that you, as a system admin, you would need to know and also practice a bit, so that you get a hang of it, and you are able to execute them flawlessly. So user add is the command to add the user. I mean, these commands are pretty self-explanatory in most of the commands in Linux. For example, user del is to delete the user. User mod is user modify. That's the short form of modify is short. Mod is the short form of modify. So this is to edit the user. Who am I is another important command, which is quite handy. It's basically, you'll know who are you logged in as, and then there is another command as ID. It gives all the information related to user ID, and what primary group it belongs to, and the list of groups, the other groups that it might be belonging to. So that was about the basic user add commands, user management commands, group management commands. So group add, group del, and group mod. These are the basic commands, pretty self-explanatory, that we need to use. Okay, now let's deep dive a bit and understand what are these files all about. Okay, etc password. So all the information related to user is stored in this etc password file. Now each of this file have a specific format. So the data in which it is stored is this: username, password, UID, group ID, a comment, its home directory, and then the shell. Shell is like, what should be my default uh, environment when I log in. We covered regarding the shells uh, in our previous videos. uh, etc group. So all the information related to group is stored in this file. So similar to etc password, so the group file would contains the group account information, and the information can also be essential, for troubleshooting, or say for security audits, and ensuring that users has only the limited access that the organization wants them to do. So this is the format: the group name, the password, the GID. GID is the group ID, and the group members, separated by a comma. etc shadow, all the password related information of all the users are stored in the etc shadow file. So this file was actually earlier world readable and used to allow the users to pull password hashes for other accounts as well. But eventually, the password hashes were moved to a file readable only by a root, which is the etc shadow. Now, if you check the etc password file, you would see X in the place of the password field. Okay, so earlier it used to be an hash kind of key, encrypted key, which used to get populated in etc password file as well. That is not the case today. So this is the format of the etc shadow: username, password, when was the last password change, what are the minimum characters of password, what are the maximum, whether I want to provide any warning, the status, and what should be the current status, and what is the if I want to change the status to. Okay, so this is about the files. Now, just one more information related to etc password. So etc password also maintains a backup of the file. I'll show you that file when we start the practicals. etc password and hyphen a dash, say. Okay, so that it happened with me as well. I was able to I accidentally deleted etc password, and then I was able to recover the original one with the etc password hash file. Okay. uh, Moving on to next, so let's do some quick practicals. Okay, so we'll cover whatever we went through. For example, the user add, user mode, user del, and the group related command. So I had already added few users, for our demo, but we'll again add it. So user add, say T1. T1 is like training one, or whatever you can denote T2. So user at T1 would create the user. Okay, and to set the password, there is another important command. I actually did not cover it in the slides earlier. Okay, so once the user is created, you'll have to set a password for it. So password is so this is the command pass wd. It's kind of short form of password, and the username. Okay, now change password for user one. Say I'll set a password and hit enter. It will just give you a warning: bad password. The password contains the username in some form, but I mean you should be it is safe to ignore it, and you can continue with your password. And you would see that it both the passwords should match. In case it doesn't match, it will give you an error. For example, let's try this. Okay, passwords do not match, and it again prompts you for that password. Okay, so over the time, the password mechanism, or the password validation has also evolved. For example, you can see on the screen, right? The password is shorter than 7 characters, so it already has some inbuilt validation itself. Okay, so we have created the user T1. Now, just for the sake of security, I'm not going to display the complete file, but you will just grab it and see. So T1 X is the password. This is the user ID, group ID. This is my home directory, and this is my default shell. Okay. Now, whenever a user is created, if I do not specify any group, a similar group with that name is also created. Now, if you check T1 in say etc group, you would see it. Okay, so I had some GT1 and then I created T1, right? So this is the simple format. It's just my uh, name, the password. By the way, you can also set encrypted password for groups, and this is my GID, which is the group ID. Okay. Now, if I want to say, for example, create a create a specific home directory for a user, uh, you know, there are various options. For example, say, okay, let's first create user with home directory. So I would do user add -d home, say my new home, and the username as T2. Okay. Now, if you check the etc password file of T2, you would see the home directory is set to my new home, right? And so that's about creating the a specific home directory. So if you are not aware of any of the command or which options to use, you can just execute help and it will give you all the options that you could utilize with the user add command. Okay. uh, so user mod is another useful command, basically to modify user. For example, let's try to modify uh, the password, or sorry, the ID of the user ID of T2. Okay. So what I'll do is user mod -u. Say I would say 98989, some random, and T2. Okay, and then I'll just see. So if you check this, you can see the user has been modified. Okay. Now if say I want to, we can try changing the group. So I had this group GT1. So we could just say user mode hyphen G and the GID. Now GID, the group ID is 1004. 1004. Before that, before we go with this, okay, let's first execute a few commands, just for the simplicity, so that we can understand it in the better way. So I'll just not execute this. So ID command, I say ID T2, it would give you information about the UID, the GID, and which groups you are associated with. Okay, so it would be easy for us to quickly check the updates for this user. And then who am I? Okay, so for example, I logged in as root, but if I do SUT2 and say who am I would say, it will print T2. Okay, and then we would go to say our next CMDs, and we will do ID22, and yeah, that's about user mode. Now user del is the command to delete that user, and you have to really have to be very careful with deleting it. So for example, we'll just quickly grep uh, both the users, etc password, and T1 and T2. So we'll just delete these two users. Uh, so there are two options for user del. So if I just say user del T1, okay, it will delete the user, but it will not delete the home directory of that user. Okay, it's still there. Now to delete the home directory of that user, I'll use an option as -r, that is recursively delete all the traces of this users. Now if I have deleted the user, now if I go and say my new home, it's deleted. So this is about the deleting the user. Okay. We'll quickly cover group related commands. So group add. By the way, one more quick quick trick to identify the commands on Linux. So if you are not sure about what is the command, or you don't know the full command, you just type some initials and press the tab twice. So it will give you all the list of commands matching your initials. So if I say group, so these are the matching group commands. So group add is the command, say gr1. We'll just quickly check grep gr1 etc group. Okay, so this group is created, and say if we want to change the group ID, so group mod is the command that we'll use. So -g is the command, is the option, and will say assign a random ID, and then the group name, which is gr1. Okay, now if you check, the ID has been changed. Now if you want to rename the group name, right, so group mode -n, say gr1 to new gr1. Okay, oh sorry, it's other way around. So I'll have to first specify the new name and then the gr1. Okay, uh, yeah, it's renamed to new gr1. Okay, and then finally about deleting the group. So group del, and say for any command, you can use -help. It will print all the related information for that command. Okay, so group del has very limited options here. So we'll just delete the group and say new. So for example, it will have to specify the new name, new gr, and yeah, it's gone. Okay, so that's all we had for today's session. Thank you for watching this video, and do let us know your comments. And if you want us to specifically cover any specific topic for Linux, do comment. Thanks guys, bye. Hello everyone, welcome to our YouTube channel. In continuation to our Linux tutorial series, today we would be talking about the shells in Linux and learn few basic commands. So this is what we are going to cover today. What is a shell, types of shell, basic commands, and man command. First, what is a shell? A shell is a program which acts as an interpreter between the kernel and the user. A quick recap on kernel. Kernel is the core interface between the hardware and the software. So it controls all the computer operations and coordinates all the executing utilities. An OS starts a shell for each user when the user logs in or opens a terminal or console window. It's an environment which helps user execute various tasks and view its results on screen. By interfacing with a kernel, a shell also provides a way for a user to execute utilities and program. So shell can also be defined as a command interpreter. Types of shell. Shells are important part of any Linux user session. We are provided with various different types of shells in Linux to accomplish this task. Basically, each shell has its own unique feature. Hence, there are many instances where when one shell is better than the other for specific requirements. Let's take a look at various types of shells we have in Linux. First is the Bourne shell, which is also known as an SH shell. So it was developed at AT&T Bell Labs by Steve Bourne, and it is also regarded as the first Unix shell ever. It is the preferred shell for shell programming because of its compactness and speed. A Bourne shell's drawback is that it lacks features for interactive use such as the ability to recall the previous commands. The full path to use the shell is bin sh and sbin/sh. The Bourne again shell. The Bourne again shell is popularly known as a bash shell. The GNU Bourne again is designed to become compatible with the Bourne shell. It also incorporates useful features from Korn and C shells. It also has arrow keys that are automatically mapped for command recall and editing as well. The command path for this shell is /bin/bash. Next is the C shell, which is also known as CSH shell. It's a Unix enhancement written by Bill Joy at the University of California, Berkeley. It incorporates features for interactive use, such as use of aliases and command history. It also includes convenient programming features such as built-in arithmetic and a C-like expression syntax. The command path is /bin/csh. Next is the Korn shell. The Korn shell was written by David Korn at AT&T Bell Labs and is a superset of a Bourne shell. It supports everything that is supported in the Bourne shell, has interactive features comparable to those in the C shell as well. It includes convenient programming features like built-in arithmetic and C-like arrays, function, and string manipulation facilities as well. The command path is bin/bin/ksh. Basic commands. So these are the basic commands those you guys are going to use, almost daily when working on a Linux platform. We would also be covering some basic examples for this command. Basically, we would be executing some commands on the Linux terminal to see how that works. So first is the ls command. It is a command to list files and directories. Then mkdir command, basically make dir command, command to create directories. Rm command is to delete files and directories. Now we also have another command known as rmdir, which is specific to delete the directories. So we would cover only the rm part of it, basically the rm command. cd command is used to navigate between directories. cp command to copy files and directories. mv command to move the files and directories. pwd command to check the present working directory, and touch command to create the empty files and also update the timestamp. So let's do some practical. First is the ls command. ls is to list the files and directories. So I've created this test directory for the practical purpose. So if I execute, let me just re-log in. Okay. So this would only list the files and directories of that present in that directory. Okay. Now few options. ls-r, it would display the files and directories in the reverse order, and then we have ls-capital R. With this, I would like to reiterate here that commands on Linux are case sensitive. So basically, if the command option is a small r and a capital R, right? So both would have different execution. So you'll have to be very careful when executing commands on Linux. So capital R would display in recursive order. So for example, say I do ls, I have a directory as n1. You would see n1 has another directory and it has another directory as well. So what I would do if I execute capital R and say n1, it would give me the list of all the directories present in that directory. ls-l is to list the directory, basically in the list format. So it will give you all the details, the permission, the owner, the size, the timestamp, and when it was created, what was the last not when it was created, basically a timestamp when it was last modified. Okay. Then ls-lh would display in human readable format. So if you see, we have a file in 2766 bytes here. It would show in the human readable format here. Okay. And then we have ls-la. A is used for hidden files. So in Linux, you can create a hidden file by appending dot at the start of the command. So if I say touch hidden, so touch would create empty files. And if you see ls-la, you will see a dot hidden file. Okay. Now if I remove -a from here, uh, the hidden file is not displayed here. Okay. Next is mkdir. So basically mkdir is to create directories. So if I say mkdir dir1, it would create a directory name as dir1. And you can create multiple directories by separated by a space, say dir2, dir3, and you will see uh, all those directories are created. So if I want to create, say, a recursive directory, for example, I want to create, say, R1, and inside that R2, inside that R3, it will give me an error saying that, R1 or basically no such file or directory exists. So it starts with R1. So if I want to create a recursive directory, I would use option -p. So mkdir-p would create all the directories in it. So ls-r, r1 would show you r1 has r2, r1, r2 has r3, and then we have r3 at this place. Okay. Then the other option to use with this -v, which is actually verbose mode. So it would give you the details on the screen itself. Say dir10. So it gave you mkdir created directory this. Okay. Now if I don't use, you must have noticed that it okay it also gives an error. It basically does a validation. All the basic validations are in place for these commands, whether you are copying or creating a directory or a file, to check whether the file exists or not. Okay. Now directory 12. So here I didn't use -v, and it did not print any message for this. Next is the rm command. You need to be very careful when using rm command. Okay, so rm command is a command to delete files and directories. So I have so I have created few files and directories for our testing purpose, so we could use them for the rm command. So if I say rm hyphen, so we'll create will delete an empty file, rm-d3, you'll notice it's asking for the confirmation. Okay, so if I say yes, it will delete it. If I say n, it will not delete it. Now if I use another option, say -f, and I delete this file, say d2, it will delete it. F is deleting it forcefully. It won't ask for the confirmation. Similarly is for directory. Now for directory, we also need to use another option with rm command. For example, if I say rm say r1, it would not delete a directory. It will say cannot remove directory uh, because it's a directory. Basically rm command, I mean, if we deleted a file, it would ask for a confirmation, but that is not the case for the directory. We have to use different options with rmr. Okay, now if I use hyphen r is recursively delete the directory and the subdirectories under it. So it will ask for confirmation, say yes. It will ask confirmation for all the subdirectories in that directory. Okay. Now, if you want to delete the directories forcefully without any confirmation, for example, I have another directory which has multiple directories in it. So for this, we could use rm hyphen rf and say n1. So it would delete all the directories recursively without asking for any confirmation. So it has been deleted. Next command is the cd command. Okay. So cd is basically the change directory. It's pretty common command between Linux and Windows user as well. So whatever directory you want to go into, you would just cd into it. For example, I want to go to say a home directory, okay, and do ls. So it would take me to the home directory. Now you are not aware or you don't know in which directory you are. You would use pwd. Pwd is present working directory. So it will just tell you where you are on that system. Okay. Now if you want to navigate to the user's home directory, whosoever you are logged in as, you would do cd and the tilde sign. So it would take you to the directory of that user. For example, I'm logged in as a root on the system, so it's showing me as a root directory. And if I want to say go into some other directory, so I would just say opc, basically other users home directory. I would use tilde and the username. So it would take me to that user's home directory. You can also use cd hyphen dot dot to go to the previous directory. Basically one directory down, one level down. You could also use cd space hyphen, which would take you to the previous directory. So whatever previous directory you were in, this command would take you to that directory. And then cd dot. So basically dot is your current directory and dot dot is the previous directory. So for example, say if I go into say usr lib gcc, right? I mean, I'm going into multiple directories, so you could go this way. And if I do ls, we have this folder. Now if I want to navigate back to, say two directories back, I want to go two directories back, I would do cd dot dot slash dot dot. It would take me to the usr directory. Okay. Next command is the cp command. Cp command is used for copying files and directories. So let's go to our directories where we have the files. For example, I've created few files here. So say D1, right? So if I say cp D1 to D2, it would copy. It would create two copies. Basically, it would copy D1 to D2. Okay. So if I want to copy the directory, so for copying directory, I have to use couple of more options. For example, if I say copy n2 to n3, it would give me an error saying it's omitting the directory. So I have to use R. R is recursive. So it would copy n2 to n3, and you will see n3 directory is created here. Okay. Now, if you want to copy, say, multiple files in a particular directory, for example, D1 and D2, I want to copy it to D3, sorry, N3. It would, this would do the trick. And if you want to copy it into another directory under the N3 directory, you would also do, say, you can specify the full path of that directory. Regular expressions. So if So CP also supports regular expression. Regular expressions, I mean, the basic one is star, like matching all the name starting from this particular alphabet or number. It would do that. For example, say release ls uh, D star. It would list everything starting from D. Now, if we want to copy, say, D star, just check what it does. Okay, so it is giving me a warning to rewrite the file. I would say yes. For the next file, I would say no. And then it omitted the other directory because D star, it consider everything, dir, d1, d2, and whatever started with D. Since we did not give any option with cp, it omitted the directories. uh, so if I want to copy a directory, say cp dir. Okay, so dir 1. Now even 1 has, say, 4 directories. I would do this: cp-ra recursively copy all. So we would copy to /temp directory. Okay, now if you see, it has created a copy of these dirs in the temp one. Okay. Next is the mv command. Mv command is used to move files and folders between the various directories that we want to. For example, say let's create few blank files. Say A1, A2, A3, A4. So basically, touch command, creates a file or updates the timestamp of that file. So if I say execute this command, it would create empty files. So you see A1, A2, A3, A4. Okay. Now if I want to move a file, say A1 to A1.1. Okay, so this would be the command. So source and the destination. So you'd see A1 has been moved to A1.1. Similarly, if I want to move A1-1 to, say, N3 directory, I would do this. So it's gone from here and it's moved to N3 directory. Okay. We could also do this for directories. So dir1, we would say dir1.1. Okay. Now let's see what happens for the recursive one, whether we need to specify any options or not. Let's test that. Okay, now n3 has multiple directories in that. Okay, so let's try to move n3 mv n3 to, say, the n3.3.1. okay, it didn't ask for basically it didn't give us the warning about the recursive one because mv considers it internally and moves everything to the new directory. Okay, uh, pwd we already covered, and then we have, say, touch. Now going back to the touch command, we created few files at say this was the timestamp of a file, right? 7:35 you would be seeing. Now if I say touch D2, let's see what. So you see the date timestamp has been updated for the for that command. So these were some of the basic commands that you would need to practice and master over the time as you continue your work on the Linux platform. Uh, Next is the command for file management. Okay, another aspect is managing the file, since it's all UI CLI based. A lot of you would be requiring to use the terminal to view the file, to edit the file, uh, to say get few words or few common stuff from that file as well. So how do we do that? So there are some commands to take care of that. First is the cat command. So it would display the complete content of the file, and then we have a head command that displays the first 10 lines of the file, and then we have a tail command that displays the last 10 lines of the file. We have more command, so more displays the file page wise on the terminal, but it also retains all the text of the terminal. For example, if we would be covering this in our practical. Less command is to overcome the more command drawback. So basically less does not retain the text on the terminal. And then we have a grep command. Now the basic usage of grep is to filter the output of the command or search for a particular text in the file, or filter specific word from the large results. So grep is also used majorly in the shell scripting as well. So let's check how this command works. Say we'll first do the cat command. So I have already one long file. So you would see cat. So it printed all the and all the contents of that file on the terminal itself. Next we have the head command. So I created a file, this file, which is like numbering. So we could know how many numbers it printed, how many lines it printed. So head num file, it would print only the first 10 lines, and then tell num file, it would print the last 10 lines. Now there is also an option, say -n, which is numbering. Now if I want to view only the last three lines, I would do tail. So it would show me the last three lines. Similarly, we could use this for the head command as well. So first three lines. And then next we have more and the less command. So the problem with the more, right? Say if I do say more long file, you would see that it added all the text on the screen itself. Basically, if it is a large file, say if we want to say I'll just copy paste this multiple times in that file to create a one long file. Okay, now if you see, it would print everything on the terminal. Similarly with the more command, okay, it would do this. Now using the space bar, you could navigate to the next page until the file is ended. Okay, now the drawback of the more command is that it will wipe out whatever was present on your terminal. So it would replace those contents, right? Now if I exit by pressing Q, the content would still be there. So that is taken care by the less command. Okay, for example, if I execute say a less command, less long file, you would see this file, say I navigate and I go back. So let's clear the terminal. This long file. Now if I press Q, you would see it is coming back to this file, to the terminal without retaining the contents of that file. Okay, so that I could view the history of my terminal, or whatever was opened, or whatever the output of the previous commands were. I could check that. Okay, that was about more and less. Grep command, for example, say I would do less grep dir1. Okay, so it would print all the matching dir1 in my ls command. So ls would show me everything, and say I would do grep a, so a2, a3, a4. Okay, now let's see how we can do that, how we can use that for a for searching a text in a file. For example, I had a word Titanic in my long file, so we could do this. Okay, it didn't. Okay, it's case sensitive. So we would also see how to grab the case sensitive one. So if I say grep, sorry, copy. So it would print all those lines which matches that word. Okay, for example, say I want to search this word. Right, so it would show me this. Now coming back to our uh, case sensitive option, so we could also use an option -I and say Titanic. Let's see what it prints. Right, it printed everything that matched. So basically I is like in case sensitive option. So that's about grep. So these were some of the file management commands. Let's move to man command. So man command is a command to display the user manual of any command that can be executed on the terminal. So it is very helpful when you want to refer to arguments for a command which we could pass to be executed. The information includes the command description and whatever applicable options are, various flags, few examples, and other informative sections like who the author is, and stuff like that. So uh, there are a lot of options which you could use for man, but yeah, I mean these are the basic one which could be very helpful. Okay, for example, say we would use, say we want to see man help for ls. Okay, so this would so these are the section. What is the name, what is the synopsis, what is the description, and what are the options, arguments that you could use. And it has loads of options, and then at the end is author and copyright, and also what is the other information that you could look for that in this command. Okay, and then say -f would display the man pages which could match the specified command name, and display the various sections that this command is present in. Okay, so this command is present in, say, section 1 and 1p. Then we have another option, that is display all the available intro manual pages in succession. Okay, now if I say man hyphen a ls, it would show me in succession. Succession is in, if I want to quit here, okay, it would still give me an option, say man next. So next is this. So if you can see this option here, right? So it would still allow me to return and go back to that help. So say I press enter, and then I will be able to quit. And then now if I want to quit, I simply press Control C or Q, which would exit the man page. The other option is hyphen W. So it would display the location of the manual page for the given command. So say man hyphen W is, this is where all the information is coming from, right? So this could also be useful if you want to know the source of that command. Okay. That's all for today. Thank you for watching this video, and do let us know in the comments if you want us to cover any specific topics in Linux, and uh, how did you like this video. Thank you. Bye. Hello everyone. Welcome to our YouTube channel. In our Linux tutorial series, we would be talking about file permissions management in today's session. So this is what we are going to cover: file ownership, file permissions, what is chmod command, modes of permissions, and then practicals at the end. So file ownership. So every file on a Linux system, whether it is created by anyone or it's a system-based file or any configuration file, has three types of permissions on it. Is assigned basically three types of permissions. So one set of permissions is for the user, the second set is the group, and the third is others. The user is the owner of the file. So by default, whoever creates a file becomes the owner of the file. Group contains a set of users. So all users belonging to a particular group will have access to the file as per the set permissions. Only the permissions which are assigned to that group would be applicable to those users as well. Others, so any other person who is not on not an owner or part of the group is treated as the others. So in short form, it is mentioned as UGO: user, group, and others. So what are file permissions? So every file or directory on Linux has three types of permissions: read, write, and execute. So read is I mean, the name itself are very intuitive. So you would know that read on means it's read only. So it would give access to open and read the file, and read permission on a directory gives access to list the contents of the directory, and it is denoted by a character R on the file or a directory. Write gives access to modify the contents of the file, and write permission on a directory give access to add, edit, delete, or rename the files, and it is denoted by the character W on the file or directory. Execute. So just like we have .exe executable on Windows, you could also have executable files on Linux, but we have to assign the executable permissions. So it gives an ability to execute the file as a program, and it is denoted by character X. Now coming to the right side of the diagram here, your picture. So you could see there are three set of permission, and then we have a file type at the start. So hyphen means it's a file. If it is D, it means it's directory. And we also have other file types. For example, for links, symbolic links, we have L, and then there are other files like a device file or a socket file. You would see some number, some character there. For this session, we'll just stick to hyphen and directory file type. RWX, the first set of RWX is for user. The second set of RWX, the permission are for group, and the third one is for others. chmod command. Now chmod is the command which is used for managing the permissions on a file or a directory. The syntax is pretty simple, so you just need to use chmod, assign permissions, and the file name or a directory name. So we would see more of this in our practicals as well. Now, what are the modes of permissions? There are two modes of permissions. One is absolute mode, and second is symbolic mode. Absolute mode is also known as numeric mode, and it allows us to change permissions for all the three owners, that is user, group, and the other. So permissions are represented in a three-digit number, that is 1, 2, and 4. 1 is for execute, 2 is for write, and 4 is for read. So for example, if I assign number 3 for a file, I would see execute and write permission. So combination of 2 and 1, addition of 2 and 1. Now if I give 6, it would say read and write. Now if I say 7, so it's like all permissions, read, write, and execute. So Linux is smart enough to identify the numbers and assign those permissions accordingly. Now, if you specify incorrect number, it has validation in place, and you would see errors printed on the screen. Zero means no permission, so you would see blank, no character for a file or a directory if you specify zero. Now, what is a symbolic mode? So symbolic mode can modify permissions for a specific owner. So I could pick for whom I want to change permissions for. Okay, so it is represented as a mathematical symbols which can be specified with user denotation, that is UGO, what we saw for user, group, others, or if I specify all, it would be applicable to everyone, so user, group, and others. Plus sign, if I use any permissions RWX with the plus sign, it would add the permissions. Minus sign, it would remove the permissions, and equal to, it will override the earlier set permission and set the new one. Okay, so these are some of the example of a chmod command itself. We'll probably execute as is during our practical and see how that looks. So chmod o equal to rwx, and the file name means it would set permission rwx for others on that file. Chmod g plus w, it means group, plus the right, I mean the first character, right? The first left hand side, whatever you would be mentioning, UGO, it would denote user, group, or others, and after the mathematical symbols, it would be the permissions, as simple as that to remember the syntax. So and chmod u minus x, it means remove the executable permissions for a user. Okay, and then you can also specify multiple user group. Okay, let's do some practicals. So I have two set of users here for our practical purpose. So one is the root user, and the third one is the normal user. Just to see the permissions that we would be, how the permissions are actually implemented and what kind of error you would see. First, let's quickly cover the permissions that we saw, right? You see that by default, the files are created with this permissions. So the first character here is the type. So hyphen means it's file, and you can see D denoted for a directory. RW is this RW means read and write permission for the owner, and then read for the group and read for the others. Okay, so since now I'm root here. Okay, I created this file, and you could see the user and group has also been assigned as root. By the way, we covered the user and group management in our previous session, so you could find that video on our YouTube channel as well. And this user is a normal user. Uh, okay, who is not part of any, who is of course not the owner, is not part of the group. So it is like he belongs to the others category here. Okay, so we'll see. We'll try to modify a file as so we have a file here from a previous practical, say num file, right? You see the permissions are rw and rr. So other don't have permissions, and at the end of the screen, or at the end of the file, at the bottom you would see this num file. It's read only, so it recognizes that the other, this is the user belonging to the other category who do not have a permission to, write or execute. So it just read only. Now even if I say try to edit this file, it would still give me an warning. So changing a read only file, say this is edit in read only, and let's see how, if I'm able to do that. Okay, no, it's I'm not allowed to do that. So what I'll do, I'll just quit the file. Now as a root, I'm the owner of the file. Okay, so let's see, I assign. So let's quickly go back to our practicals here. Okay, so what was the right permission? 2. Okay, uh, so so the current permission here is rw. Okay, 644. Okay, so the current permissions is rw, the addition of my read and write numbers, and this is 4. Okay, now if I want to use the absolute method, what I will do is I would say 6 4. I'll keep the group permission as same, and then I'll use 6 for the others. It means it will provide read and write access on the file. And say this. Now let's try editing the file again. Okay. Now you see, you will not see any warning at the bottom, and I am able to edit it. This is edited after changing permissions. Okay. So I'll just save it, and then I'm able to save the changes as well. Okay, so this is how uh, permissions on the file is been used. Now if you see the directory, right, I'm in this directory. Okay, so there is a directory Linux cmds, and the permission for this directory is rwx rx 7, I think 55, yeah, right. So read and execute, so 755. And you would see we don't have write access on this directory. So since I don't have write access, let me try creating a blank file. Okay, what happens? You would see an error, cannot touch blank file, permission denied. Okay, now if I say chmod 747 and say Linux cmds. Okay, let's see what. Okay, I kind of changed the permission for the group as well, and assigned all the permissions on the others. Now I can, let's see what happens now. See, I'm able to create a blank file, create a new file basically. This is the new file. right? So this is how the permissions on the directory and file works. So this was about the absolute mode. Let's quickly cover about the symbolic mode. Now, just like we assigned the permission for our, say, num file, so you would see the num file has, yeah, you can see the owner and group, right? So the training one user created the file, the blank file, and he by default is the owner and the group of that file. Okay, so coming back to our symbolic mode of permissions. For example, I want to say roll back the write permission. So what I'll do, ch mode o is other, remove the write permission and the num file. Okay, so you would see the file permissions have been removed. Now let's try editing that file again. You would see a read-only error here, and then I'll not be able to trying to edit. Okay, it will not allow, right? And then in similar manner, say I want to uh, assign permissions to everyone. Okay, so I'll just use all equal to rwx the file name. Oops, my bad. There is some syntax error. So you could see, oops, I lost my network. So I'll just log in as training one for this one, and then I'll go in this directory. Okay. So yeah, coming back to what we were doing is we were trying to assign the permission using the symbolic mode. So let's try assigning the executable permission. So ch mode, say u plus x and the num file, right? So if you see, you would see the executable permission. By the way, you must have noticed the color change, right? So there are also uh, the color is tied up with a particular file in Linux. For example, the green file is most of the times the default settings we have on Linux. It means it's an executable file. It has executable permission on it, and then we have a blue color reserved for directories. Of course, there are configurations you can change it, whatever color you want. Okay, yeah, I think that's all on the permissions front. So do let us know your comments on the video, and what all topics you would like to cover us in our series. Okay, that's all for today. Thank you. Bye.
Hello everyone, welcome to our YouTube channel. In our Linux tutorial series, we would be talking about package management. So this is what we are going to cover today. What are packages? What are package repositories? Understanding package dependencies, tools to manage packages, common usage of those tools, that is RPM and yum, troubleshooting, and some quick practicals. So basically, what are packages? So in general, across all the operating system, packages are archives that contains any precompiled binary software files, installation scripts, configuration files, their dependency, and other details about the software. For example, the version number of the software. Now, packages are specific to a particular distribution and formatted as per the supported format. For example, for Windows, you have exe. Similarly, you would have .deb for Debian and Ubuntu-based systems, and you would have .rpm package extension for RHEL CentOS-based systems. Now, another common way of bundling the software is also a .tar file, which has all the required code in it, and the dependencies are also packaged in it. So, all the required data is already bundled in that tar file. So you just need to untar it and run the installer script. Every tar file or every package would have its own installer script, and it will do its job of installing that particular package. Package repositories. What are package repositories? In most cases, the packages are hosted on public repositories available over the internet, which are also known as repos. A repository can contain a single package or thousands of other packages. Now, most Linux distribution today have their own package repositories. So each one of them host their own package repositories and their dependencies. So a lot of software companies also use this concept of hosting their package on repositories and providing updates to their customers. So it's like just a way for them to provide easy way of upgrading their software or their package. Now, understanding package dependencies. What are package dependencies? Dependencies for any installable software are common across any operating system. For example, even if you're installing, say, a Java on a Windows server, it would require some dependencies, right? So that's across operating systems. So in Linux, each package contains metadata, that is detailing the additional packages those are required for that package. Now these additional packages are known as dependency. And now a single package can have multiple dependencies, and these dependencies are also affected when upgrading or removing the package. Tools to manage packages. Now, every Linux distribution has their own tool to manage packages on the system. Now, the most common CLI tools, say for Ubuntu, for RHEL based system, it is RPM and yum, and for Ubuntu and Debian based system, it is apt-get and dpkg. So, in our practicals, we would be talking about RPM and yum. A lot of Linux systems also provide UI based package managers, which becomes very easy for an administrator to install packages. So if they are not aware about these CLI tools, they can simply access the UI and manage their packages. Okay. Now, what are the common usages of RPM and yum? So RPM is the most widely used command to install packages on the system, on basically Red Hat, CentOS and Fedora based system. Now some of the common usage, say RPM-QA. QA is query all, so it would query all the packages. RPM-IVH, it is used to install packages. RPM-UVH, you would see U is capital, that is U is used for upgrade. Now what is IVH and UVH, right? So I is install, V is verbose. So you can see a small image on the right hand side of the screen. So V is verbose, it would print messages that verifying preparing, and H is used for hash. The hash you see, it would print the progress in the hash format. RPM-E removes the packages. RPM-QL get the location of the files installed by the packages. Now, for if for example administrator want to know where, on what all locations the packages installs this file, so he would use this command. Sorry, rpm-qf is checks the specified files belong to which package. A qf is query file, so in front of that qf I would provide the path of the file. Basically, if an administrator want to know which package does this file belong to, so it would use this command. Common usage of yum. Is another tool which is more common, since it queries the packages directly from the repo, and it's also easy to use since it also takes care of all its dependencies. Some common usage is, these are all basics. So yum installs the specified files. Now this yum is also very intuitive, as in, you would know yum install would install the packages, yum remove would remove the packages. So these are like this makes very easy for any administrator to use this tool. Yum search searches packages which matching the keyword, and yum update updates the specified package. Now you need to be very careful when using yum update. For example, if no package is specified, it updates all the installed packages on your system. Okay. Troubleshooting. So few common scenarios encountered in package management. So dependencies. So some package need specific version as their dependencies. So for example, if you are installing a particular version of Oracle on your system, and it requires a specific version as a dependency, so unless you install that specific version of dependency, you won't be able to install that Oracle package on your system. Cyclic dependency is also encountered sometimes, meaning the main package and the dependency packages are like dependent on each other. So you would, for example, how you would see it when you are, how would you encounter it when you are trying to install it? For example, you are trying to install package A, and it asks that this is dependent on package B, and when you are trying to install package B, it is complaining about it's dependent on package A, right? So this is known as cyclic dependency. Now how do you resolve the cyclic dependency? Is you specify both these packages together when installing, so that they would recognize, okay, I have package A, I have package B, and they would do the installation. Uninstalling. So most of the times you would see dependency errors while uninstalling the packages too. And you really have to be very careful when uninstalling the packages from the system, as you might uninstall critical packages that is required for any software application, or you would uninstall the dependency which is like needed for some other package, right? So in case you don't want to uninstall the dependency, say you want to install only that package without affecting the dependency, you would use the no deps option with rpm-e. So it would ignore the dependency and remove the packages. Again, you have to be very cautious when using this option. Quick practicals. So let me just quickly get my screen. Okay, so we would we would cover the common usages. We would cover options from our common usage slide, just to practice what we learned. So rpm-qa, as I said, it would query all the packages, right? So if I want to specify only say get only a particular package, if I know the package name, it would give me that. So rpm-query all and vim, right? So you can see it didn't print because maybe the package name didn't match the word we provided, right? So another quick solution for this is using the grep command. So grep, probably I'll cover simple bash scripting commands in another tutorial, but grep is like it will match the keyword from your whole list and will print the results. Now let's see what are the options we have. So VIM has like four packages starting from VIM, right? So for example, if I specify VIM hyphen common, it should print that name. So basically we need to provide the whole name and it would print the rest of the details, right? RPM hyphen, say we would use query files and say VIM common, sorry, query location. So we want to see what all location the VIM has installed its file, this command, this package, right? So these are the location where it installed all its files. Now if I want to know hyphen, say which package does this file belong to, I would use rpm hyphen qf. Say I would just copy and paste. It would give the name of the package. Okay. Similarly, we would quickly check yum tutorial. So if you now regarding the help, right, if you are not aware of any of the options or you want to know what all options, so you just say rpm and it would print all the options for it. Now these are like options you would, some are like intuitive, some you might not be aware. As covered in my previous session, you could use man command. So man rpm would give you all the options. For example, rpm hyphen I is install, rpm hyphen u is upgrade, e is for erase, and all the other options that you have. And that's similar to your yum command as well. So yum would give all the options, print all the options here. Okay, so let's see, yum, say we'll just try installing, say, VIM package. Now since I already have this VIM package installed, it would give me an error, right? So if VIM enhanced, this particular package is already installed and on latest version. So in case this package was an older version, it would went ahead and gave me an option to upgrade this to the latest version. Since it's already on the latest version, it didn't do anything and just printed this message for us. And now yum search, say, VIM. Okay, so it would print all the, sorry, it would print all the matching keywords. So basically we are specifying a keyword to search VIM, the name, the package name, right? So similarly, if I want to try, say, FTP, let's see what errors, what results it gives. All right, so any packages that matches FTP in it, it prints all the matching keywords, right? Yeah, I think that's all for today. So yeah, thank you for watching this video, and do let us know your comments, and if you want to cover us any specific topic, do comment on this video. Thank you. Bye.